Hello everyone. Hope you are able to see me and hear me.
Yes, sir. Good morning, sir.
Good morning. Nice to see you all today. Hope you are all enjoying the lectures. I'll be very happy to have the critical comments. Any comments if you have on the lectures given, I'll be very happy to get them. Though I got several queries. Sometimes I'm unable to correlate the timing which you have mentioned and the question which you have. For example, what is happening regarding groundwater level at 12:09th minute, right? When you are mentioning the timing, you can also add more information about the question you have so that even if the timing doesn't tally with the video, I'll be able to answer. Maybe I will, if if you don't have any questions, I will go through the question and answers one after another. Um, First question, I think what I have is, question, what is happening here? Maybe how can we process, how can I use the GRACE data? Unfortunately, I have not gone in depth about the utility. I just mentioned about the utility of GRACE data. I didn't talk about how the data has to be processed. I feel that is beyond the scope of this course, which covers a very vast aspect of sustainable groundwater management. There are a lot of literature which are available to process the data. Processing is also not very cumbersome. The data is easily downloadable. After downloading the data, we have to use some geospatial tool. Maybe even the Google Earth Engine can be used for this purpose to understand or to process the data. Right? Unfortunately, I'm unable to give much more explanation than this. If you have any specific question on that, you can again write to me or ask the same question in the discussion forum. Then another question is on why we have not covered all the questions that are asked in the assignment. The idea of the whole program is not to feed all the information to you. You need to also look into the material that are available elsewhere. For example, in the books which are mentioned in the course page, as well as information that are available in open source. Every week, there will be about 15 to 20 assignment questions. Out of that, 4 or 5 questions, I would not have explicitly given the answers during the lecture. So we also need to judge how you are able to cope up with some aspects that are beyond what we are discussing in the course. So I expect you to also look into the resources that are available elsewhere, right, to answer some of the questions for which you may not get information from the lecture itself. Is it possible to give certification exam online? Not really. You have to attend the exam in one of the examination centers. Right? With regard to centers abroad, I think sufficient information will be available with the NPTEL website. Otherwise, you can specifically ask, I am from this place, whether there are any centers nearer to my location. Right? As far as I understand, there are no centers outside India. Then groundwater in India, there is one question on groundwater in India. what is happening at these questions. I'm finding it a little difficult, right? 20.58. Right. The question which you have asked is not relevant to the timing which you have mentioned. Right. At 20.58 seconds, we are looking into the sustainable development. Please describe the water availability and distribution in India. Groundwater is available in different formations. There is one part of this lecture which gives an idea of groundwater provenances of India, right? How groundwater occurs in different provinces of India. The most important one is the Indo-Gangetic Plains. In southern peninsula, groundwater occurs mostly in massive rocks except for the coastal regions. The map showing the distribution of groundwater occurrence in India is given this lecture. If you have any specific doubts, you can again ask. If you are here, you can again raise your question, right? Any specific question during this discussion meeting itself. Then I have then the next question is also about examination centers abroad. I have already explained to you. Uh, Assessment about assessment about how satellites are used in India to assess water table. Probably I would not have explained very clearly. We cannot deploy satellites to assess water table directly. Right? What I had mentioned is the variation in the Earth's gravity is picked up by these twin gray satellites. Right? The satellites go over the surface of the Earth one after another, as you can see and you can imagine this as a satellite. The elevation of the satellite gets changed due to the gravitational attraction. Right? Wherever there is higher gravitational attraction, the satellite goes little bit downwards. Wherever the acceleration due to gravity is little less, it goes little bit upwards. So it is something like a table tennis ball. The satellite goes up and down depending upon the Earth's gravity. This is picked up by the distances between the two satellites which go one after another, which are known as Grace 1 and Grace 2. Sometimes popularly it is also called as Tom and Jerry satellites. Based on the differences in the distances between the satellites, that is controlled by the gravity at that particular spot. We make use of this gravitational variation, right, on a monthly basis. These two satellites go over the same spot on the surface of the Earth once in a month. So every month, if the gravitational value vary, the only reason for that is the change in the terrestrial water, right? Terrestrial water, or what do I mean by terrestrial water? I don't also only mean the surface water, both surface water as well as water in the soil water zone and groundwater. So we indirectly relate the variation in Earth's gravity to the water mass. That is what I had mentioned. So making use of this GRACE data, we are approximately able to evaluate the total water mass beneath one pixel. That pixel is also a very large size pixel. So we are able to get only approximate information about the change in the water mass, but not precisely the water. Hope I am clear. The next question is on Kathmandu, to know that there are people attending from Kathmandu. Uh, yeah, so you can certainly enroll this course. With regard to examination, I think you need to attend the exam in one of the examination centers. You cannot attend online. This question is on What is happening at here? The speaker is introducing about the guidelines of the NPTEL Open Online course. As you would have already seen the guidelines, 25 marks is from the assignments which you submit every week, and remaining 75 marks is for the proctored examination held at the examination centers. The next question is on stress strain on groundwater. I think we are not really discussing about the stress strain on groundwater, but we are looking into how groundwater is also undergoing compression. When groundwater is over withdrawn, the groundwater occupied by the pores is getting emptied, due to which the soil may slightly expand. In the pore space, due to the withdrawal of soil, will get slightly compact. On the other hand, when there is more recharge, water gets compressed and the aquifer skeleton expands. This is the cause for some, for example, land subsidence. When you over withdraw groundwater in regions where we have confined aquifer, confining layer at the top may lose out part of its water to the aquifer at the bottom, due to which the confining layer's thickness will get reduced, leading to land subsidence. Hope you are referring to this only. And another thing for which we use the stress strain is for compressibility of the aquifers. As I had just now mentioned, when the recharge is very high, in the case of confined aquifers, water is getting compacted. This is what is known as compressibility, right? Whether the compressibility of water makes the storage bigger, or compressibility of the aquifer skeleton is responsible for the storage of water beneath the surface. In that regard, we would have used the word compressibility. Then the next question is on yeah, this is again what is happening in I will just see one. This is also on the procedures of NPTEL program is explained. Sufficient information is also available on the website. If you have any specific question, you can write to us again, right? No need to mention the timing of the video also, right? You can just ask your question directly. I think I'm through with the questions which I have in the mailbox. Now I leave it open for you to raise questions. If you don't have any question, then I'll continue to talk. Maybe if you have any questions, you can type in here also. Is there examination center in New Delhi? Yes, certainly there will be a examination. Yeah, you can, with regard to this time of submission, yes, you can also resubmit your assignments, right? Is it possible to get PowerPoint presentation? I think you are going to be given the lecture notes. Once again, I'll read the questions here too from the beginning. Can you, yeah, of course. Can you explain seawater intrusion once again? Yes, of course. So what is seawater intrusion? Lateral inward movement of seawater into the coastal aquifers is known as seawater intrusion, which means the land part of the aquifer is also connected to the sea in many occasions, especially when the land adjoining the sea is, let us say, unconsolidated. Imagine a situation where you have a beach, right, with unconsolidated sediments beneath. In such a situation, groundwater occurring in that formation below the coastal area will be getting discharged into the sea, right? Which is known as submarine groundwater discharge. The reverse of this, suppose on the land side, when we withdraw groundwater, the hydraulic gradient will get reversed. That means from the land side, groundwater is getting discharged to the sea, which means groundwater head is much higher than the sea level on the land side. When you withdraw more groundwater, groundwater head will fall, isn't it? As the groundwater head falls, this will promote more and more seawater intrusion. We have seen a very simple relationship that governs the seawater intrusion, which is known as Gaben and Herzberg relationship, which is an approximate relationship, but with that we can understand. When the height of water table from the mean sea level is, let us say, 1 meter, then the location at which the seawater freshwater interface that occur below sea level will be 40 times up. Hope the concept of seawater intrusion is clear to you. I'll once again repeat, lateral inward movement of seawater in the aquifers is known as seawater intrusion. This will happen even if you don't withdraw groundwater, because seawater is slightly denser than the freshwater. So you will have a small wedge of seawater freshwater interface in the coastal aquifer. If this is the land side, this wedge will move toward the land side when we over withdraw. This is what is known as seawater intrusion, right? The salinization of groundwater due to vertical movement of seawater from the backwaters. They are not really called as seawater. If it is not clear, you can message me again. The course material is, yeah, there is a provision to, because this NPTEL is in work for several years, so they know the procedures very well. Right, as per the procedure, as per the protocol of NPTEL, they'll be sharing the lecture materials. The next week there is examination center. Certainly there will be a examination center at New Delhi. I have pending assignments. I think you can submit the assignments. Any comments from you, Indu, or anyone from NPTEL with regard to the data time given for them to submit the assignments? If you know, you can tell also, Dr. Indu.
So 1 and 2, the last date will be August 6th. And for week 3, it is on 13th August. They have to adhere on the deadlines.
Oh, okay. So they cannot submit beyond the deadline. Am I right?
Yes.
Okay. Hope it is clear, right? You have to adhere to the deadlines. And out of the 12 assignments, minimum 10 has to be submitted. Am I right, Indu? You can explain about that too. Every week, they have to do one assignment. Is it mandatory for them to?
All assignments are mandatory.
Are mandatory. Okay, fine. Okay. And you are from Nepal, right? I don't, Indu, there are no examination centers abroad. Am I right? Maybe you can.
Examination centers are there.
Okay. Are there examination center at Kathmandu?
That I have to check, sir.
Yeah, you can also check, Mr. Pavan Kumar. You can also check. All information is available in the NPTEL website. If some information is not there, you can write to us. Right? In New Delhi, yes, there is a center. Does the course also qualify faculty development program? Yes, of course. Yes, I think this course also qualifies for FDP. Am I right? Is there anyone from NPTEL attending? Yeah, it is for FDP. I think there is a mention about this in the course page. Many studies indicate there will be rise in sea water level. What could be the impact of this? Right. I think I'm presenting a case study in some later weeks uh, on seawater intrusion, if I remember right. Wherein I have explained very clearly, but anyhow, nevertheless, I can repeat again the same here. As the sea level rises, what will happen to the groundwater level? As sea level, as I was just now mentioning, sea water will also naturally found intruded in aquifers where there is no over exploitation of ground. Right? If you can look into my lecture notes or my lectures again, especially little later, I think there will be a week which is devoted for seawater intrusion. Normally, groundwater level or head will be higher than the adjacent seawater level. Even in such a situation, there will be seawater intrusion because density of seawater is marginally higher than the fresh groundwater. In such a situation, as the sea level is rising, the extent of intrusion of seawater will also increase, due to which groundwater level also will rise similar to the rise in sea. Am I clear? Right? As the sea level rises, groundwater level also will rise in the aquifers, and the lateral extent of seawater intrusion, or what we call as wedge of seawater intrusion, or we used to also call it as toe of seawater intrusion, will also begin to move toward the land side. Okay, this will happen every second. That means we should be also not be very much alarmed, right? Seawater intrusion is not going to happen overnight. It is happening as we are discussing right now. Okay, so as the sea level rises slowly, the wedge of the seawater intrusion will also advance toward the land side. Correspondingly, the groundwater level also will rise. You will see a case study later on during this course in which we have numerically modeled this effect. Still is on. Cover software applications. Yeah, I am making a mention of some softwares, but certainly we cannot have any live classes on the application of software tools. However, there are plenty of free software that are available, right? One such is the Model News, right, of United States Geological Survey. There are well-established discussion forums associated with such freeware groundwater models. You can explore about these. There are different softwares which I talk about. However, we don't have any specific classes on exclusive application of these courses. I think a link of examination centers has been already posted in the message box by Indu. What will be the high tide effects and low tide? I can before that. Can you explain hydrological cycle once again? Of course, right? What we see every day is the hydrologic cycle. That means we see rains. We also seen the water which got stagnated outside our home is lost. Right? They are all due to the functioning of the electromagnetic, due to the functioning of sun's energy, right? Due to the function of sun, what happens is water which we see outside gets evaporated. Part of the water goes as evaporation. Very simply, hydrologic cycle is defined as endless circulatory movement of water from the lithosphere to the atmosphere, from atmosphere back to the lithosphere as well as biosphere. Biosphere, what I mean is water that is used by the plants and grass. Okay. So this endless circulatory movement of water between these spheres is known as hydrologic cycle. Very simply, water from the oceans gets evaporated. The evaporated water goes to the atmosphere and it gets condensed, forms cloud. It is unable to bear the water. Again, it falls down on the surface of the earth as well as on oceans as rainfall or precipitation or snowfall. The water which has fallen on the surface of the earth, part of it runs on the surface, part of it gets percolated, goes and joins with the ground. So groundwater is also part of hydrologic cycle. Hence, I have introduced about hydrologic cycle. The subject of hydrology deals with the study of various components of hydrologic cycle, whereas in this course we are looking into mostly about groundwater, little bit on the interaction between surface water and ground. Hope I am clear. The next question. The next question is, what will be the impact of, Mr. Vinod Kumar is asking, what will be the impact of high tide? And very interesting question. There are a lot of research work has been done on that. As I had explained about sea level rise, right? If you look at my picture, right, if you consider my arm as the sea level, during high tide, slowly the sea level goes up. During low tide, it comes down. The variation between high tide and low tide varies depending upon the location. Right? For example, in Chennai, the difference is about 1.15 meters between high tide and low tide. As the due to tidal variations, groundwater level also will try to synchronize with the tidal level variations. There will be some time lag, right? So in reality, as the tide level rises, slowly groundwater level also will rise. As the tide level goes down, groundwater level also will go down. There will be a time lag. Making use of this time lag also, researchers have tried to estimate the hydraulic conductivity of the coastal areas. To answer your question very simply, groundwater level also will respond to the tidal fluctuations. Regarding next question, do we have examination center at Ranchi? You can have a look at the link. She has again shared. Yeah, that is it. Right. Any other questions if you have, you can also type in your questions right now. So until now, we have seen how far is the impact of, how far is little tricky to answer. The impact of tidal level fluctuation with regard to distance from the coast will obviously vary depending on the hydrogeological situations, right? If it is a sandy aquifer, if it is nicely connected to hydraulically with the sea, the impact can be seen up to, based on my experience, I'm telling, maybe up to few hundred meters, right? Not beyond that. Based on the impact, we can understand how conductive the formation is, isn't it? Suppose if the effect is seen to greater distance, what does it indicate? The hydraulically coastal aquifer is nicely connected with the sea, which means hydraulic conductivity of the formation is high, due to which when the tide level rises, if groundwater level quickly responds to that, what does it indicate? Both are nicely connected and hydraulic conductivity is comparatively high. Right? So we cannot directly answer how far will be the impact, maybe to few hundred meters. Can we identify lineaments physically on the ground? Yes, we can, right? Sometimes we'll be able to identify, not always. The advantage of using remotely sensed images is Hope you are able to see me again and hear me again. Hindu, can you hear me?
Yes, sir. Yes.
Okay, right. I'm back. Hence, for example, I was talking about, we are discussing about lineaments. If the lineament is due to dike, which dikes are intrusive rocks, right? These dikes can be very easily located on the surface. Right? The very thin linear features from taking clue from remotely sensed satellite images, we'll be able to locate on the field. Right? That is the question. Physically, we can see them on the ground. How to determine the safe feed from aquifer to prevent over extraction? Right? Though I have discussed about safe field as of now, little later you will know safe field is also not the ideal limit up to which we can pump. We have to pump groundwater in order to sustainably manage. Right. So to answer your question on how to determine safe field, what we are currently doing is what is the quantum of recharge that has taken place in a year. For example, in India, we account the water budget based on water year, which is from June to May. Since we have monsoons during October, November, December, or from July until December, we have two important monsoon period. We account for water budget from June to May. How we determine safe field? Let us say in a given area during last year, 1000 liters of water got recharged from rainfall. How much of water we can pump from the same region? Pumping should be less than 1000 liters. This is the very simply, this is the concept of safe yield. That means we don't want to withdraw groundwater more than what we have received from the principal recharge source. The principal source of groundwater is the rainwater. So this is how we can estimate the safe yield. For example, in India, I made a mention also. Central Groundwater Board assess the dynamic resources block wise or firka wise. What we are doing is based on simple groundwater fluctuation method. For example, before the beginning of the year, groundwater table was here. At the end of the year, if the groundwater table is at the same place, what does it mean? We have not over withdrawn. That means we were within the safe field. That means from the fluctuation, we try to estimate what is the quantum of rainfall recharge. Before rainfall, where was the water table? After a major monsoon event, where is the water table? Based, we know what is specific yield. Right? I also gave an example within a box, right? 1 cubic meter of box. If the specific yield is 0.2, 0.2 meter cube of water can be added into that box. There was also one simple assignment question, if I remember right. When the water table is lowered by 1 meter over an area, if the specific yield of that formation is 0.2, how much of water we would have withdrawn? We can estimate, isn't it? So making use of this simple concept, we estimate the quantum of water which we would have pumped or the quantum of water which we would have recharged, using which we estimate safe. We try to maintain abstraction should be less than the recharge. This is the concept of safe field. However, safe field alone is not sufficient because if you don't pump, groundwater will be moving and contributing to different ecosystems. Right? When you pump groundwater within the safe limit, even then you are capturing some groundwater which otherwise would have gone somewhere for the benefit of someone else or some other ecosystem. That is the concept of sustainable yield, which you will learn little later. is the connectivity between shallow? How do you determine safe field to prevent over extraction? Yeah. So as I told you, to prevent over extraction, we have to limit ourselves to the quantum of water that was recharged during the last year or what is likely to be the recharge during the forthcoming year. Then what is the connectivity between the shallow aquifer and open water level and a confined aquifer at a bore well level, right? How can it vary from place to place? If from your question I understand, in the case of shallow wells, the level of water which you see in the well is the actual water, right? Water table is thus very much connected with the shallow aquifer. When you pump water from the well, automatically aquifer water will get discharged into the well. Suppose if this is the well level, this is the boundary of the well, right? Just outside the well, water level also will be at the same elevation, right? So when you withdraw groundwater from the well, the surrounding formation will slowly release water into the well. Why? This is governed by the head difference. Always the head difference play a role in groundwater flow. As the head in well goes down compared to the groundwater head outside the well, the water from the formation will be seeping into the or flowing into the well. In the case of a bore well in a confined aquifer, the same thing is applicable. Only difference there is pressure difference. Right? In the case of a bore well penetrated into a confined aquifer, water level raised in the bore well. Why? Due to the pressure. Confined aquifers are aquifers in which water is held in with higher pressure. In other words, in unconfined aquifers, at the water table, water pressure is equivalent to the atmospheric pressure. Right? At the water table, hydrostatic pressure is equivalent to the atmospheric pressure. In the confined aquifer, the level of water in the well, at that particular place only, hydrostatic pressure is equivalent to the atmospheric pressure. Whereas at the top of the confined aquifer, water pressure is or hydrostatic pressure is higher than the atmospheric pressure. So, the pressure of water in the confined aquifer is higher, whereas in the borehole which you are mentioning, you see a water level, but just outside the borehole, whether there will be any water, there won't be any water, or that water may be from a different aquifer. Do you understand, right? The water which you see or which you collect from a borehole penetrating into a confined aquifer is from the confined aquifer. So just outside the well, the aquifer is not connected to the well. Am I clear? Hope I'm clear, right? So in the case of shallow aquifers or shallow wells, both the water table and the water in the well, they are one and the same. In the case of confined aquifers, water is coming from deeper aquifer. It has raised due to the pressure. Just outside is not connected, hydraulically connected to the connectivity. What is the reason for different intensity of arsenic and fluoride contamination at different places? Is it because of our exploitation? Due to the geographical factors here in Bihar, it is very high, despite over 70% of the region is flooded. And certainly, we cannot directly attribute the problem of arsenic and fluoride contamination to overexploitation. Even without overexploitation, right, the concentration can be higher. What is the major reason for presence of fluoride and arsenic in groundwater? You are also going to see this little later, right? Maybe in the 4th or 5th week is going to be exclusively on groundwater quality. But anyhow, right, I can tell you the major reason is the geogenic sources, which means natural sources. Rocks in India, right? The same rock which is occurring abroad, right, has got slightly lower fluoride. Right? Rocks in India has got very high amount of fluoride comparative to the same rock occurring elsewhere. That is the reason for presence of fluoride in ground. The same is also applicable to arsenic. Right, in intergangetic plains, some sediments has got slightly elevated concentration of arsenic, due to which arsenic concentration is higher, especially in shallow aquifers. Due to overexploitation, this problem may get aggravated, right? But we cannot attribute overexploitation as the cause for fluoride-rich or arsenic-rich groundwater. Is it also the geographical factors? Yes, location is important because, as I told you, the release of fluoride and arsenic is from the rocks or geological formation. So, depending upon the location, rocks has got different concentration of fluoride and arsenic. And obviously, during heavy monsoons, as you have mentioned, 70% of the region is flood prone. If the recharge is very high, rainfall recharge is very high, the dilution effect will bring down the concentration of these elements. Right? Anyhow, we are going to see about this little later. You can reserve your question. If you still have doubts, you can ask me after you have seen after we complete the water quality week. Is there any change in open well tube well hydrology? Your question is not very clear to me, but imagine that you are terminating your well in the same aquifer. If you consider the aquifer as unconfined aquifer, what is unconfined aquifer? Aquifer which doesn't have any top confining layer. That means groundwater may have some connection with the atmosphere through the unsaturated zone. Can you explain once again? Please mention about what? Right? The next. I'll go back to the same question. The difference between open well and tube well. There are some differences between the well hydraulics part between open well and small diameter bore well. How does the pumping
Sir, my
respond?
question was that, sir, excuse me, sir, I'm Ishwarjan from
Please.
Okay.
Please.
Sir, my question was that during the monsoon, our open wells are very much filled of the water. Maybe the water level goes to 10 meter. Then in the summer period, it goes beyond 70 to 80 meter.
Okay.
So is there any difference in, especially Rajasthan state, during monsoon water table is very high. During non-monsoon months like February and April, the water table goes to 100 meter below the ground level. So what is the difference? The aquifer is same.
If the aquifer is the same, the difference is due to the abstraction and the recharge. Right? What you have said will happen anywhere, isn't it? Right? So when there is sufficient input, the water level rises. After that, there is no recharge, but we continue to pump groundwater. As we withdraw more and more groundwater, water table goes down. Right?
Yes, sir.
So when you plot the time versus water table, it follows a kind of a cycle, sinusoidal curve, right? Which is true for several regions in India, since the rainfall happens only during specific part of the year. To answer you, In the case of open well, that is why we are going for tube wells. Suppose if you go for a open well, that there is some limitation. So beyond certain depth, we cannot go for a open well. Now everybody have started going for wells, so water table goes beyond the depth of the open well. That is why we have gone in for tube wells. So to meet our water requirements, even during difficult times. Right. So the level of water fluctuation depend very much on the recharge and pump. That is why we are talking about sustainable. Can you explain once again what that person can ask again? What do you mean? What do you want once again? I'll be happy to explain. In flood-prone area, recharge is more. Is it possible contamination can occur due to? Absolutely, yes. Right? Floods are always not going to help us, especially when you have contaminated water bodies. Right? When during flooding, there can be some dilution, but there can be also some adverse effects. Both can happen, right? Yes, the adverse effect can happen when you have very much contaminated surface water, surface water bodies, right? Maybe sometimes rivers or lakes may have domestic sewage or industrial wastewater would have got collected in surface water bodies. When such surface water body swells during floods, that contamination is spread over a large area. Everywhere the contaminants can recharge and join with the groundwater. So I think I'm presenting a case study on that. Is there a method to prevent the effect of high tide on the very? Yeah, there are methods which we will look into during a week on seawater intrusion, but these measures are not really environmental friendly, right? For example, if you cut off the connection between the aquifer and the sea with a impermeable wall, yes, we can overcome the effect of high tide and low tide. But is that a environmental friendly measure? Certainly, isn't it? So ideal way to manage this situation is to live with what is happening, right? That means we need to manage our groundwater resources wisely so that the effect of high tide and low tide is not going to cause greater impact to the coastal groundwaters. I think I'm not getting any more question. The person who has asked me to explain once more or once again can please question. You can type in your question again. If not, I think until now we have seen lectures of first 2 weeks, right? So in that we have some of the questions which you are asking will be answered later on. For example, water quality issues, seawater intrusion, subsidence issues. We are going to look into it a little later, but please understand this is a very vast course in which we are introducing you some concepts of sustainable groundwater management. We will not be giving or we will not be deep diving into any particular aspect. For example, there was a question on how to process the GRACE data. That is beyond the scope of this course. So I'm happy at least you got some idea about GRACE data. It is for you to ponder more or discuss with me, right, during your questions. But I won't be able to explain all the integrities of processing of GRACE data in this course. Okay, that is beyond the scope of this. Similarly, there was another question, what are all the applications of various software tools? That is also not within the scope. I'm introducing you so that at least I'm happy you are aware of these tools now. It is for you to ponder for more information. Nowadays, there are a lot of open source software related to groundwater modeling. There are also some interesting sites with online. I think there are some you can search. Maybe otherwise, I'm also showing some links during my lectures. You can look into these links, right? And every software tool also has a discussion forum, as we are discussing now, right? As and when you download and start using that particular tool, if you have any questions, you can raise them in the discussion forum. There will be someone who will be able to help. So during the following weeks, we will look into the other aspects of the various other aspects which you are asking right now, right? Little later, you will be able to get answers. For example, in the next week, we will be discussing about aquifer test as well as sustainable yield. From say field, what is sustainable yield? We will be discussing. There will be also, I have also be able to convince several experts, right, who have done considerable work on a particular aspect. They are giving some expert lectures. You can also see the list of expert lectures as well as the topics on which they are going to talk about in the course webpage. Make best use of these lectures too. In the following weeks, I think I'm seeing now in the 6th week, we are going to look into hydrochemistry and groundwater quality, wherein I'm also talking about arsenic and fluoride. And if you have any other questions, you can type in your questions in the box, or you can also ask me. Is there is it possible to share the details of all participants in chat? I think this discussion forum, you are able to, whatever you are asking is seen by everyone, right? You can also use the same discussion forum for cross learning, right? And then can we discuss the use of HGM maps for decision making. Maybe you can be very specific, Mr. Harish. You can ask your question explicitly. Can we use groundwater management? GM, yeah, GM crops. Is there any threats to groundwater? I don't think there will be direct threat due to GM crops to groundwater. It's my personal opinion. Can we use GM? Is there any threats? Yeah, I have answered this. Do you say water quality will be better in boreholes? Please explain. I don't think I can give you a direct answer. But in general, deeper groundwater will be little bit safeguarded from the surface contamination. Isn't it? It is quite obvious. If in the shallow wells, in shallow groundwater will be more susceptible to contamination due to whatever disturbance which we make at the surface. We may be storing large amount of waste. Municipal solid waste is dumped on the surface. The leachate will have greater effect on the shallow ground than the deeper ground. So we can say deep groundwaters are expected to be comparatively better in general. Right? Sometimes deeper groundwaters, due to longer period of residence, may acquire the properties of the rocks, inherent toxicity. Right? As we were discussing right now, a while ago, rocks which are richer in certain elements such as fluoride may slowly release large amount of fluoride in deeper groundwaters. Whereas in the case of arsenic, it is vice versa. Shallow groundwaters are rich in arsenic. Deeper groundwaters in Indo-Gangetic plains are comparatively of better quality. So we don't have direct answer, but in general, right, anthropogenic impact, that means man-made contamination, will be less pronounced in deeper groundwaters, which we will learn during the 5th week. Possible to provide course material? Yes, the entire course material will be given to you. So water quality is better in boreholes. Yeah, comparatively, boreholes may have better water quality, but it also depends on the location. If you take coastal aquifers, deeper waters will be saline. Preferable to drill only shallow wells in coastal areas. If you drill deeper, you will get lot of water, but it will be very saline. So it is very much dependent on the location as well as the hydrogeological conditions. As JJM guidelines recommend the use of HGM maps developed by ISRO for specific recharge structures. Yes, certainly. Right? Hydrogeological maps are mandatory to plan for recharge structures. Right? We need to identify ideal sites for planning for recharge wells or percolation ponds, isn't it? We are going to discuss about this while we are going to look into the chapter on, sorry, a week on, I think it is on the, let me check, right? We are going to look into that when we are going to see sustainability and aquifer recharge. Week 5, we are going to look into different methods of managed aquifer recharge, wherein we will also look into what are all the site conditions required, right? Without a ideal situation, right? Ideal subsurface formations, we cannot plan for managed aquifer recharge. That means what is the critical thing which is required? You can answer me, right? First of all, formation should be able to store the water which we recharge. So we need highly porous formation. The upper zone, that means the unsaturated zone, should be able to allow the water to transfer from your recharge structure to the groundwater zone. That is why it is mandatory to look into hydrogeological map to plan for such structures. Are you able to see me? Right? What is the next question? Problem of yeah. Yes, sir, right. When the groundwater is getting contaminated due to sewage, certainly we will have all these issues. Uh, yes, possible, right? Old canal, right, which has carried sewage, right? There can be problem due to smell. Sometimes also natural, right? Whenever you have sulfate rich formation, there can be also a geogenic reason for the smell, but mostly it is attributed to contamination due to mixing of our domestic sewage. Right? So, what is the way forward? Maybe we need to look for deeper wells in such locations, or if you are sure if it is due to a domestic sewage which is flowing adjacent to your well, we have to shift the location of the well. Before that, maybe we can think of flushing the well, right? That means we try to clean up the well, add some maybe kind of a bleaching powder, right, to clean up the well. And this is done by several borehole well developers and drillers. That means flushing is we try to redevelop the well. Well development, I think I am making a mention of well development during my lectures, right? Otherwise, you can also follow the procedures given for well development. You can check whether well development is able to improve the quality of water in the well. At least for some time, you will be able to get rid of the problem of water quality or bad smell in the. Hope the discussion was very fruitful to all of you. I'm happy to look forward to have your views on this discussion forum. Any other questions if you have, you can raise them in the discussion forum. Thank you very much. for joining in this discussion forum. Looking forward to see you all very soon in the next discussion forum meeting. Meanwhile, if you have any comments, questions, you can ask them in our discussion forum. Thank you very much. Wish you a nice day. Anything else to be told, Indu? I think it is for a 1 hour session. I think we are beyond the time allocated for us. Thank you very much.